We've looked at a couple of types of graphs so far, column graphs and histograms. Well, today we're looking at line graphs, and in particular, we're looking at line graphs that use time data along their horizontal axis. Now, these are really good for spotting trends in anything that you're investigating over time. We put the time on the horizontal axis, and then whatever we're measuring goes on the vertical axis. Now, if you're recording something over time, then it's most helpful if you're recording your data at regular intervals. And what I mean by that is, let's just say you're plotting the growth of a plant every day for 3 weeks. Then if you measure that plant at the same time every day, then the time in between the measurements will be consistent. Similarly, if you're looking at, say, the temperature over a year, then having a measurement for each month sort of keeps it sequential. Data points are basically just drawn as dots. So you can see on my example here, I've got the average monthly maximum temperature in Canberra, and I've actually just made this data up for the display here. Now this graph has got a title, that's always important. It also has headings for what we're measuring on each axis. So here we're measuring in months, and it's got the months listed. Here we're measuring temperature in degrees Celsius, and it's got the scale clearly there. Now, when you've got a measurement to make or a data point to plot, they're plotted as actual dots. So you do that first, and then you can join your dots with straight lines. So that's a bunch of individual little straight lines. It's not one straight line sort of through the whole lot, unless, of course, they all line up perfectly. Now, we tend to describe trends by their direction. So you can look at a section of a trend and say this is a downward trend here because something's going down over time, or we have an upward trend over here. Obviously, it depends on what you're measuring. If we've got something like temperature, then every year the temperature gets colder and then it gets warmer again. So we've got upward and downward trends one after the other. If you're measuring, say, the height of your little brother in the last 5 years, that's going to be generally an upward trend because it's very unlikely that they will have got shorter. So use sensible words to describe trends if you're asked in a question. Is it an upward trend or is it a downward trend? It's quite straightforward. And if a trend has data points that are roughly in a line, a straight line, then we say that generally it's linear. So I wouldn't say that this one is generally linear because it's going down and then up again. But if I was to say graph the height of a small seedling every day for a month, and I noticed that it was growing a consistent sort of amount like this, the dots might be not perfectly in a straight line, but once I join them up with a whole lot of little straight lines, you'd say that that's roughly a linear trend because it's going up generally sort of in a straight line. Now in this exercise, you're expected to read information from a graph quite often, more often probably than having to draw a graph from the information. So here I've got a graph of showing the distance that I am from home over time when I go for, say, a walk or a run one day. So I've got time on the x-axis here. Time seems to start in this experiment at 12 o'clock and finishes at 12:50. And I can see how far away from home I am at any one time, anything up to 4 kilometers. So what I recommend you do with a graph like this is sort of try and tell a story with it. At this time here, I'm no distance from home at all, so I must be at home. As time starts ticking away, I'm getting further and further from home because at 10 past 12, I'm now 1 kilometer away from home. So I've somehow moved 1 kilometer in 10 minutes. I seem to keep on going at that same speed. Now, can you see how the gradient of the line here is really reflecting how fast I'm going? Because after all, if time ticked away a certain amount and I got a long way from home, I'd be going faster, wouldn't I? Whereas if time's ticking away and I haven't got very far at all, then I must be moving much slower. So I can see here that I've picked up the pace a little bit at 12:20 until 12:30, and I'm now 4 kilometers away from home. All right, something's going on here. What could it be? Well, I haven't got any further from home in that 10 minutes. So if I haven't moved anywhere, perhaps I've stopped for a rest. And then this looks like the fastest part of the journey over the whole time, doesn't it? And it looks like I've arrived back home here because my distance from home at 12:50 is 0. So I must be at home. So tell a story with it like that. Then you can answer questions really quickly and easily. So how far from home was I at 12:20? Well, have a look along till you get to the 12:20. And make a vertical line going upwards, and from there you can read across with a horizontal line going across, and you can see that I was 2 kilometers from home at that time. How long did my whole run take? Well, if I left at 12 o'clock and got back at 12:50, 50 minutes. quite straightforward. What could I have been doing from 12:30 till 12:40? Well, in that time, I didn't get any further away from home, so I must have been maybe having a rest. Or at least I was stopped. I wasn't moving. How fast was I running between 12 and 12:10? Okay, well, it took me 10 minutes to cover that time, and in that time I went 1 kilometre. So let's think, if I go 1 kilometre for every 10 minutes, how many kilometres would I be going in an hour? All right, well, how many 10-minute intervals are there in an hour? There's 6, aren't there? So if I go 1 kilometre in 10 minutes, I would go 6 times as far in 6 times as long. So say to yourself, this is to this as that is to that, to solve questions like that. And I can see that to get from here to here, I've multiplied by 6. So I need to do the same over here. And I can see that I was going at 6 kilometres per hour. What was the furthest distance I was from home? Well, the furthest I got from home was 4 kilometres away. So see, sometimes you need to look for something on the x-axis and make a vertical line and a horizontal line to read off the corresponding y-axis marker. And other times you need to look for the y-axis marker and read off a corresponding x-axis time.